Hello and welcome to the tutorial Mechanics of Materials. In this, now we are going to deal with Poisson's ratio, that symbol is nu. So here you have taken two different types of member. One is a rectangular member, second is a circular member. So this is solid member, and how that Poisson's ratio is going to deal with, that we'll see here. At first stage, it is shown that there is a members which is rectangular members and circular members having length, having width. For circular members having length and having diameter. So this is shown here. So how we are going to deal, and how while it is experiencing a tensile load, compressive load, and both the way. So here we are seeing that a structure is experienced with tensile load and compressive load. Then what going to happen? If this is experienced with loads, tensile load and compressive load, so what is going to happen? So let us see how we are going to find out the Poisson's ratio. First stage, it is shown that there is a solid member. Then here solid member with rectangular cross section and solid member with circular cross section. So next, here if tensile load is applied, that length of the member going to increase, and same time the width of the member going to decrease. So two phenomena will happen here, that length will increase and width will decrease. Again, in second case, if compressive load is applied, length is going to reduce and width is going to increase. Similar fashion, if you see the circular section, here also due to tensile load, the length of the member is going to increase and diameter is going to decrease. In second case, due to compressive load, length of the member going to decrease and the diameter of the member is going to increase. So these are the two cases. So what happens here? There is an increase in length by delta L. Here you can say, so at the both end, as this tensile load is applied, so here delta L by 2 at one side and delta L by 2 at another side. Altogether it is delta L. Here also, while we are considering the width also going to reduce or going to increase with quantity delta B. In similar fashion, here length going to increase, length will become L plus delta L, and here length going to decrease, L minus delta L. Here also length going to increase, L plus delta L, and here length going to decrease, L minus delta L. And here diameter going to decrease as diameter going to increase. Here width going to decrease and width going to increase. So these are the changes happening. So here in second stage, whatever the changes going to happen with the application of loads, that is tensile loads and compressive loads. Then next, how we will define the Poisson's ratio. So here that axis is shown, it is shown that in x direction, this is the lateral direction, that I am assuming here x direction is the lateral direction and y direction is the longitudinal direction. Then what going to happen? Next we will see here, under, as I explained in the figure, that same thing I am writing here, that under tensile force, dimensions in the longitudinal direction is increasing, and dimensions in lateral direction is decreasing. So this is seen in the figure clearly. And the same way, under compressive force, dimension in longitudinal direction is decreasing and dimension in lateral direction is increasing. So both things we have seen. So now under tensile force, and that too rectangular cross sections. So here this is a rectangular cross sections as we considered. So longitudinal strain. So here we are going to deal with a strain. First is a longitudinal strain in the direction of length. What is going to happen? Change in length divided by original length, that gives the strain. But as during the with the application of tensile force, what is happening? Length is going to increase. Means if there is an increase, it will become positive. In another way, here in lateral direction, width is decreasing, so that will take negative. If there is an increase means positive and decrease means negative. Same times, if you are taking compressive force, so what is happening? Due to compression, due to compressive force, that length going to shorten or going to decrease. It means that strains, longitudinal strain will be negative. Means there is a increase in the there is a decrease in the length, it will become negative. But in lateral direction, the width of the member is going to increase. It means there is a positive increase in the dimension. In same way, if you take the circular section, similar things will happen. And here also, while considering the tensile force, longitudinal strain will be positive, lateral strain will be negative. Why? Because if length is increasing, means dimension is increasing, positive, dimension is decreasing, negative. Same thing will happen under compressive force, dimension decreasing, negative, dimension increasing, positive. So now we'll define the Poisson's ratio, that generally we write a negative of lateral strain by longitudinal strain. So how it comes when we are taking lateral strain or longitudinal strain? So this depends on the nature of forces applied. Here, from the findings what we defined earlier, from this, for rectangular cross section specimen, here under tensile force, what will happen? Lateral strain means laterally dimension going to reduce, means there is a decrease in lateral dimensions, it will be negative, and increase in longitudinal direction, that will be positive. So overall it will become negative. Same way, if you will under compression, means that length is going to decrease, means this will be negative, and width is going to increase, this will be positive. Overall it will become negative. Same, if you are taking a circular cross section under tensile load, so here diameter going to decrease, it will be negative, and length going to increase, it will be positive. Overall negative of lateral strain by longitudinal strain. And in similar fashion, while we are taking under compression load, means nu is equal to, under compression load, diameter going to increase, it will be positive, and length of the member going to decrease, it will be negative. So overall negative of lateral strain by longitudinal strain. So this is the concept of Poisson's ratio, how we define this, and here we have been defined. So this is the main concept of Poisson's ratio. Thank you for watching this lecture.